Let's take a look at 5.3's notes. In these notes, we're going to go over how do you go from a graph of a parabola. So how do you go from being given a graph of a parabola, and then how do you turn that in to a quadratic equation? So a graph to a quadratic equation. All right, a couple of things, first of all, that we've been going over at the beginning of every section so far of Unit 5. A quadratic equation is any equation where the largest exponent is 2. Quadratic equations, always when graphed, make graphs called parabolas. A parabola is a U-shaped graph, okay? And remember that the U-shaped graph could go upwards or downwards. So it's going to be a downwards U, or it's going to be an upwards U, okay? All right. So the first thing that I want to do is I want to go over the different possibilities of what a positive parabola with 2 x-intercepts would look like, what a positive parabola with 1 x-intercept would look like, and what a negative parabola with 2 or 1 x-intercepts would look like. So in order to do this, let's go ahead and draw in each part here an x and a y axis. Oh, don't forget to put the arrows at the ends of the axis. And whenever we're drawing an x and a y axis here, we're going to always have 4 quadrants. X and y axis. Arrows on the end. And then, as you're drawing this, you could listen and draw at the same time. And then what I'm going to do is, I'm going to show you an example of each one of these 4 different possibilities of what might happen when you end up graphing a parabola. Okay, now, these are only 4 of 6 possibilities that could happen. These are probably the most 4 common ones. All right, so the first one, what's an example of a positive parabola with 2 x-intercepts? So when we're talking about a positive parabola, what that means is that the parabola is going to be going upwards. So an example of a positive parabola with 2 x-intercepts might look something like this. It's going to be a parabola that is going upwards, and it's going to intersect or touch the x-axis 2 times. Okay, now this parabola could be shifted to the right, it could be shifted to the left, it could be shifted down, basically as far as we wanted to, or it could be shifted up a little bit, but to have 2 x-intercepts, it's going to cross or touch the x-axis at 2 different distinct points. Okay, the next example would be a positive parabola with 1 x-intercept. So what this would look like would be is you're going to have a parabola. It's going to be going upwards like a U. And then since it only has 1 x-intercept, that means that it's going to touch the x-axis only once. So it's going to kind of skim by and touch the x-axis just once. So there's an example of a positive parabola with 1 x-intercept. Okay, the next ones would be a negative parabola with 2 x-intercepts, and then a negative parabola with 1 x-intercept. So if a positive parabola means that the parabola is going upwards, then a negative parabola would obviously mean that the parabola is going downwards. And to draw one that has a negative parabola that has 2 x-intercepts, you would just make a parabola. It would be an example of a parabola that is going downwards, and it touches the x-axis at 2 different distinct points, like there and there. So there's an example of a negative parabola with 2 x-intercepts, and then a negative parabola with just 1 x-intercept one type of example would be like this. It would be a downwards parabola, and then it's just going to touch the x-axis once. So it's going to kind of skim right on the x-axis, touch it once, and then take off down in the other direction, okay? So these four examples right here are probably the four most common examples. And now just for fun, and I'm not going to charge you extra for this, I'm going to draw an example of a positive and a negative parabola with no x-intercepts at all. So to do that, what you would see in the positive parabola with no x-intercepts, what you're going to do is you're going to see a parabola. And if it's positive, it's going to be going up. But if it doesn't have any x-intercepts, that means it will never touch the x-axis at. So it's going to be, one of these would always be shifted up into either quadrant 1 or quadrant 2, or a combination of the two quadrants like we have in this example here. Okay, the example of a negative parabola with no x-intercepts would be it's going to be a downwards parabola, perhaps like this right here that I just drew. And notice that downwards parabola right there, did it in the wrong color. I'm going to transfer it into green. It never will touch the x-axis at. Okay, so when we're talking about parabolas, these are kind of the 6 different possibilities that might occur. You could have a positive or a negative parabola. Remember, parabolas will never go sideways. And then, whether it's positive or negative, it's either going to always have 2 x-intercepts or 1 x-intercept, or it might have no x-intercepts at all. Okay? Now, what we're going to do is we're going to learn how to read a graph of a parabola and then read that graph and convert it into the quadratic equation that would eventually make that graph. Okay? And the process is actually pretty cool how it works. It's pretty straightforward too. It sounds scary, but the process that we're going to use to do this it is basically a multi-step process. So this is the process. Step number 1 is you are going to identify the x-intercept or intercepts coordinates. Okay? Then, step number 2, you're going to write a 2 parentheses equation. Then, step number 3 is you're going to use an area model to multiply step 2. So whatever you get in step 2, you're going to use an area model and multiply it. Then, the fourth thing that you're going to do, and number 4, you're going to write the quadratic equation. Okay? All right. So let's say you have a graph, and let's say that you have a parabola that is a positive parabola, and it looks like that right there. Okay? So, here's what you have to do when you, and let's say on this positive parabola, the x-intercept, there's your 2 x-intercepts right there, those purple points. So let's say they are identified as the point 2, 0, and the point -4, 0. And then let's say the vertex of this parabola is identified as the point -1, -4. Okay, now, what you need to do to write the equation of a graph is that you need to identify the x-intercepts. You have to know the coordinates of the x-intercepts. -4, 0, and 2, 0. That's going to be step number 1. The vertex will come into play sometimes, but not all the time. Okay, but you have to identify the coordinates of the x-intercepts. Okay, then what you do, and so that's step number 1. Step number 2 is you're going to write an equation with 2 parentheses. You're going to write a 2 parentheses equation. Here's how the equation is going to look like. You're going to write y equals, then you're going to set up 2 parentheses. At the beginning of each parentheses, you're going to put the variable x. And then next to the x, you're going to put the opposite of whatever the x-intercepts values are. So if one x-intercepts value is -4, 0, the opposite of -4 is +4. So in one of the parentheses, I'll put it in the first parentheses, you're going to write x plus 4. In the other x-intercepts x value is a +2. So in the other parentheses, you're going to write the opposite of +2, which is -2. So your 2 parentheses equation is going to be y equals, first parentheses x plus 4, second parentheses x minus 2. Notice the +4 is the opposite of the x-intercepts x value of -4. And then the -2 is the opposite of the other x-intercepts x value, which is +2. Okay, that's step 3. You write the opposite values of the x-intercepts. Step 2, I mean. Step 3 is now we're going to incorporate the area model, and we're going to multiply out the equation. X plus 4 multiplied out with x minus 2. So we're going to draw a 4-part area model. Put x plus 4 at the top, put x minus 2 down at the bottom, and then we're going to fill in the 4 boxes of the area model. In the top left box, we're going to put x squared, and that's because that's the result of x times x. In the top right box, we would put a 4x. 4x is the result of +4 times x. In the bottom right box, we put a -8. -8 is the result of +4 times -2. And then in the bottom left box, we put a -2x. And that's because that's a result of x times -2. And then this area model, when I simplify it, it leads me to step number 4, which is what the quadratic equation is. So my quadratic equation is going to be y equals, so I'm going to write the same equation as step 2, but instead of writing the parentheses, I'm going to write the multiplied out version, which I get from the area model, which is x squared. Then I'm going to combine the 4x with the -2x by adding them. That would be +2x, so x squared plus 2x, and then -8. And that's the equation that you get. So the graph that I started with here of this positive upwards parabola with 2 x-intercepts, it would create the equation y is equal to x squared plus 2x minus 8. Okay, let's do another example so we can see how this works out for us here. Okay, next example. Let's go ahead and draw an x and a y axis on your graph paper. You might have to use the back of the graph paper if you run out of room. That's okay. We're going to do 2 more examples, by the way. Let's go ahead and on this one, let's draw an example of a upwards positive parabola, but that has only one x-intercept, like this one right here. And let's say that the x-intercept has the coordinates of 5, 0. All right? So, and by the way, that 5, 0, that x-intercept, it's also the vertex of the equation. So let's go ahead and so step number 1 is identify the x-intercepts. Well, we just identified it. It's right there. It's the coordinates 5, 0. Step number 2 is we're going to write a 2 parentheses equation. So we go y equals, we're going to draw 2 side-by-side parentheses. Each parentheses starts with the variable x. And then inside the parentheses, you're going to write the opposite of the x value of the x-intercept. Positive 5 is the x value for my x-intercept. The opposite of positive 5 is negative 5. So I put an x minus 5 in that first parentheses. Okay, now, because there is not a second x-intercept, what that means is that your second parentheses is simply just going to be x. There's no number to put the opposite of next to that second parentheses is x because there's not a second x-intercept. Okay, so that would be step 2. Then step 3 would be use the area model and multiply out step 2. Now, for this one, when we use the area model, we're only going to have a 2-part area model. X minus 5 along the top, x along the side. Okay, the reason there's only 2 boxes, so to speak. And now we're going to fill them out. The left box would be x squared, the result of x times x. The right box would be negative 5x, which is the result of negative 5 multiplied with x, which means that I now move on to step 4, which is I write my quadratic equation. Y is equal to x squared minus 5x. There you go. Y equals x squared minus 5x would be the quadratic equation for the given parabola in example number 2. Okay, one more example. Once again, you might have to go to the back side of your notes. It's okay if you have to go to the back side of your notes. Let's go over what happens if the parabola is a negative parabola. And then we're going to go over not only is it a negative, but what do you do if it has a negative with 2 x-intercepts? Okay, like this. Here's my negative. This is going to be my negative parabola, like that. The first x-intercept has coordinates of negative 10, 0. The second x-intercept has coordinates of negative 1, 0. The y-intercept's coordinates are 0 and negative 3. I'm giving you some information here. And the vertex has coordinates of negative 5.5, 7. Okay, now, and I ask you to write the equation for this graph right here. Now, I purposefully gave you too much information to write the equation. Why is that? Well, here's why. Step number 1 is always identify the x-intercepts. Negative 10, 0, negative 1, 0. Really, that's all you need to know to make out a possible quadratic equation of the parabola. Okay, so you really don't need the vertex. In some instances you do, and you really don't need the y-intercept. In some instances you might, but you definitely need to know the coordinates of the x-intercepts, which would lead us to step 2. Step 2 is where we write the 2 parentheses equation that we're going to use to multiply out to get my quadratic equation. Okay, each parenthesis starts with the variable x, and then I'm going to write the opposite of the x values for the x-intercepts. So I would have x plus 10 in one of the 2 parentheses, and I would have x plus 1 in the other of the 2 parentheses. Okay, now if you switched it around and you said x plus 1 in the first parenthesis, x plus 10 in the second parenthesis, that is okay. That would not affect your final equation. Now I'm going to take that x plus 10 and I'm going to multiply it out with the x plus 1. I'm going to incorporate the area model. I'm going to have a 4-part area model here. X plus 10, I'm going to put along the top. X plus 1, I'm going to put along the outside on the left. And then I'm going to fill out the 4 pieces of my area model. Top left is x squared. Top right would be a 10x. Bottom right portion would be a 10. And bottom left portion would be a 1x, or just an x. Okay, which leads me to step number 4, which is going to give me my equation. Y equals x squared. Then I'm going to combine the 1x with the 10x by adding them, plus 11x, plus 10. And what do you know? I have an equation. That's a quadratic equation. Okay? Now, but there's one more thing I have to do in example number 3 that I did not have to do in example number 1 and number 2. Here's why. There's one more thing. In example number 3, it's a downwards or it's a negative parabola. In example number 2, we had an upwards or a positive parabola as we did in example number 1. So when you have a downwards or a negative parabola, after you make your quadratic equation, there is always one more step that you have to do. This is what it is, and you do this step every time. You have to distribute a -1 into the equation. Whatever quadratic equation you get, you are going to have to distribute a -1 into that quadratic equation. Which, when I do that, I would get -1 times x squared is -1x squared. -1 times positive 11x would give me a -11x. And -1 times positive 10 would give me a -10. So my actual quadratic equation is y is equal to -1x squared minus 11x minus 10. Okay? And the reason why you have to distribute that -1 into your quadratic equation is simply because the parabola is going downwards, which makes it a negative parabola. So I have to incorporate that -1 to make up for the negative parabola. Okay, one more step when you have a negative parabola. All right, there's 5.3. How to take a graph of a parabola and then how to work through what would be 4 steps to write the quadratic equation of that graph.